I just wanted to go over this problem, 1141-30, because I know that it causes some slight confusion in students. So it's about Manuel. He has a 1,000-gallon tank, and the tank fills at a rate of 0.5 T gallons per minute. Will the tank overflow in an hour? So what I mean by or what the book means by y equals 0.5 t is that every minute the rate of change is different. So at t equals 0 minutes, the rate of change, and I'm going to just keep writing rate of change, not the number of gallons total, but the rate of change would be, if I plug in 0 gallons per minute. At t equals, let's say, 20 minutes, the rate of change, or how fast the water is going into the tank, would be, okay, if I plug in 20 times 0.5 is 10 gallons per minute. So if I were to graph this, what this is going to look like is it's just a line, 0.5 t gallons per minute. So don't overcomplicate it, just graph 0.5 t. So my x-axis kind of becomes my t-axis. So t is time in minutes. And then my y-axis is going to be gallons per minute. It's the rate. My y-axis is going to tell me the rate. So it's not going to tell me the total number of gallons. It's telling me gallons per minute. It's the rate of change. So again, it's 0, 0. I'm just going to go ahead and graph 1 hour. So it's 60 minutes. So at 60 minutes, if I plug that in, I would have half that amount for gallons per minute. So I'm going to say that's 30 gallons per minute. And that's the rate at that particular time at which water is going into the tank. So it looks something like this. So a lot of students tend to try to graph what the total amount of gallons is immediately, but I would recommend you not do that. Just graph exactly the equation you're given and just change your y-axis to be what makes sense in the context of the problem. So in this case, the y-axis is rate. It's the number of gallons per minute that water is entering the tank. So will the tank overflow in an hour? So there's many different ways that you're supposed to just kind of explore this at this point. You don't necessarily need to you don't need to find the equation for the total amount of gallons. It's kind of beyond you at this point. You will learn more about that like near the end of the year or even next year when you take calculus. So for now, what I would expect you to do is just think about what's happening at each minute. So at 0 minutes, I have 0. Ignore my phone. I will answer that later. So at first, it's nothing is going in. Then at 1 minute, my rate is 0.5. So let's pretend like from 0 to 1, that is going to be 0.5. That's how many gallons have gone in. Because I'm saying for 1 minute, it's a rate of 0.5 gallons per minute. So over the course of 1 minute, that would be a total of 0.5. Okay, and then let's add that to what happens between 1 and 2 minutes. Well, between 1 and 2 minutes, now my rate is at 0.5 times 2, which is at 1. So now I'm going to just say that's 1 gallon per minute. So I'm sorry, it's 1 gallon per minute. So over the course of 1 minute, that's a total of 1 gallon. And then from 2 to 3, so if I plug in 3, now I'm at 1.5 gallons per minute. So let's say for that minute, it's going to be 1.5 gallons. And so if I add all these up all the way to minute number 60, when I have 30 gallons per minute going in, so I've got at the 60th minute, or the 59 to 60th minute, I'm saying that's a total of 30 gallons that have entered over the course of that minute. So again, this is per minute. So I'm just saying, okay, for each minute, I'm going to add up all those numbers. And it says in the CPM book that you can actually like for the teacher's edition, it just says you can just like add up all these numbers. Like that's something we expect students to try. So you can either do it that way and just enter into your calculator 0.5 plus 1 plus 1.5 plus 2. And you'll have to do that for a bunch of these numbers, which is maddening, I understand. If you remember from Algebra 2, if you remember how to use a sum, or if you know how to use a sum, you could also say, okay, if I'm adding up all the numbers in this formula from 1 to 60, or well, yeah, from 1 to 60, you could do it that way. So if you know how to do this in your calculator and create a summation, you can do it that way. If you don't know what I'm talking about, don't worry. We'll do more about summations soon in a different chapter. But if you know how to do it that way, you can do it that way. It is quicker than having to enter all of these numbers over and over, but you can also just do that. Now, another way to think about it, and this is kind of the real method, but again, this is an exploration, so I don't want you to stress out too much if you didn't get here. The other method is to actually realize that it's the area under the curve. If you think about the area of any one of these squares, so the base is number of minutes, and the height is gallons per minute. Well, area is base times height. If I take the base of minutes and I multiply that by the height of gallons per minute, I end up with the total number of gallons. So I can actually just find the area under the curve. Basically, another way of thinking about it is I'm adding up all of these different heights. Okay, even though I've been saying we're just assuming that like, okay, it's over the course of 1 minute, over the course of 1 minute, over the course of 1 minute. That's actually not exactly true, because at 1.2 minutes, it's filling up at 0.6 gallons per minute. And at 3.4, it's filling up at 1.7 gallons per minute. Like in actuality, it's increasing consistently over time, the number of gallons per minute at which the water is flowing into the tank. So if you think about it, I actually need to add up all of these different heights, okay, at 3.1 and 3.2 and 3.3 and 3.4, and even smaller intervals than what I'm saying out loud, at 49.001 and at 49.002 and at 49.003. And I'm adding up really a huge amount of these. I'm approaching an infinite number of them. So if I were to do that visually, what you can see, what am I shading the area under? I'm shading the area under the curve, which is this entire triangle. So that total area gives me the number of gallons, and it's 1/2 base, which is 60, times the height, which is 30. And that ends up being about 900 gallons total. Now, if you do it using this method, I believe from memory, it's like 915 gallons. So any one of these kind of exploratory methods, I would say one of these three should give you a near correct answer. But the overall question is, will the tank overflow? And no, the tank will not overflow, because the tank is 1,000 gallons, and the tank is not filling up quite that quickly. We're short about 100 gallons. So if you did one of these three methods, that's great. If you have your own method, you can ask me about that and let me know if there's something else I'm missing here, that you found a different method that might work. But any one of these is fine. And yeah.